So today I am going to talk about JDK or Java Development Kit. So it is a backbone of our Java programming language. So many people think that it is just a collection of software tools to run our Java application, but which is certainly true, but it is much more than that. JDK is a development kit which provides all the tools necessary for our Java program to run. So, so this JDK is very important part of our day-to-day life. It runs applications like from mobile applications to web servers, from financial systems to our game development. This JDK is present everywhere, and you might think that this is one of the most important application which is running all over the world. So the next time you are using an application, then you might think that all behind those application there is a JDK, which is the unsung hero of, who is running that application. So this JDK consists of number of tools. Like first, it consists of a compiler. So what compiler does is it actually compiles the .java file into bytecode. And then we have another component in JDK, that is debugger. So debugger is used to test our programs, that whether each and every code is running properly or not. So it sets the breakpoints between them, and it checks each line by line that our code is running smoothly or not. And along with that, JDK also consists of document generator, which generates the document required to load the class. And then it consists of JRE, which provides the runtime environment or the minimum requirements to run or execute our code. JRE does not consist of any tools like JVM, but it consists of many libraries and deployment tools which are necessary to run our program. So it consists of plugins, and all the libraries are predefined libraries like java.util or utility library or java.lang libraries. It consists of plugins and JDBC. So it provides all the necessary tools which is required to run the program smoothly, and it makes sure that our program is platform independent because it consists of JVM. So JVM consists in both of them. It is also present in JVM is also present in JDK and also in JRE. The JVM which is present in JDK is responsible for developing the program, but the JVM which is present inside JRE is responsible for running the program or executing the program. So JDK also consists of JRE, inside which we have JVM. So now let's talk about JVM's architecture. So JVM will first take an input as .class file, which comes from the compiler. So it will start working on this .class file, which is also the bytecode. So what JVM is, it is an abstract machine which actually executes our code, which is also a heart of our Java programming language. So this JVM's architecture consists of three components. First, it has a class loader. So in class loader subsystem, we have further three phases. So the first one is class loading. So what class loading will do is, it will load the class into our Java's workspace, and it will provide memory to each memory fields, methods, and whatnot. So the work of class loading is to load the class, in which we have three class loaders. So the first one is bootstrap class loader, which will load all the predefined classes or libraries, and it will load the Java's archiver file or the .jar file. And then it has subclass loader, which is extension class loader, which will load the .ext file. And again it has a subclass loader, which is an application class loader, which will load the .class file which we actually writes the code. After successful class loading, then it moves on to the linking phase. In linking phase, there are another three phases, which is verification, then preparation and resolution. So verification is important because the verifier acts as a gatekeeper. So it makes sure that no corrupt file goes through and it will create a wreak havoc later. So it makes sure that our code is structurally correct. It also checks that our code came from valid compiler or not. So that's why a verifier is very important in Java. And then after successful verification, it goes on to preparation phase in which all the default values are assigned to the variables and fields. And then we have resolution. So in this phase, whenever we create a class and put it into another class, so this class will be referred in symbolic form. So it must be implemented. So in resolution phase, the class which is inside the class, which is in symbolic references, it will be implemented, or the symbolic references will be replaced with the original references, and then our code will be started executing or implement that particular class. So the resolutions work is to simply replace the symbolic references into original references. And then finally we have initialization phase in which all the original values assigned to the variables and fields, and our execution from top to bottom starts from this phase. After all this, the memory is allocated into each fields and methods and classes. So in Java, there are 5 types of memory. So the first one is method area. In this, all the static fields or classes or static members or static blocks gets memory inside method area. So method area creates at the startup of our JVM. So it will consist of all these. Apart from method area, then comes heap memory. So inside heap memory, all the objects are stored and the instance variables get memories inside the heap memory. And whenever we create a string, it gets memory inside the heap memory. And then after heap memory, we have stack area. So stack area will be created as per the number of threads. So each thread will create its separate stack area. So in stack, all the local variables will get stored, all the variables which had reference to the objects will get stored, and many other things which are stored in stack memory. So it acts as a RAM of our JVM. And then we have PC registers, which holds the count of the currently executed method. So the work of PC register is to keep the count of a method which is getting executed. So it keeps the information, and or we can say that PC registers maintains the proper flow of code. And then we have Java's native method, which stores the native interface, which gives the memory to native interfaces. After allocating the memory into these 5 memory areas, then comes our execution engine. So execution engine is the most important part of Java or JVM, because it actually converts the bytecode, or which actually converts the bytecode into machine code. Or this is the part where our code gets actually executed. So in this we have interpreter, which interprets the code line by line. But interpreter has one problem, that if a method is frequently called or a field is repeatedly called, then it interprets that particular code line by line, which makes our code slow. To overcome this drawback, we have JIT compiler. So what JIT compiler does is, it took that particular method or field which is repeatedly called, and it compiled that further into native code, so that our system's operating system can read that particular code and execute. So it makes our program more efficient. So with the help of JIT, we save time, and which makes our code more efficient. And then after JIT compiler, we have garbage collector, which automatically deallocates the objects or anything which is not useful or which has no references. So it reclaims the memory whenever the whenever the field is not useful. So it is one of the most important feature of Java that it provides Java collector, where the programmer does not have to worry about deallocating memory. So the work of Java garbage collector is to destroy the objects which are not useful or which has no references. So it eliminates the dead code inside our program. Then after Java garbage collector, we have Java's native interface. So what Java's native interface does is it provides a medium to interact with the code which is written in foreign language. That is, if a code is written in C++ or another language, so we can use, so Java's native interface provides a medium, or it acts as a translator to interact with that code which is written in foreign language with our Java's code. In this way, we can optimize the full power of other languages as well as Java's language. So Java's native interface is another very important feature. And that was all from my side. I hope you learned something during this video. My name is Aftar Mandal. In short, or in summary, all I wanted to say is these three components, JDK, JRE, and JVM, are one of the most important concepts to be learned by a Java developer. So understanding these three concepts is a must for a Java developer. So that was all from my side. My name is Aftar Mandal. I will see you in the next video. Until then, goodbye.